Hello. Today we are going to be constructing arithmetic sequences, and there'll be two parts to this. So let's go ahead and get started. All right, so we're going to explore arithmetic sequences. Our example is you can order tickets for the local theater online. There is a fee of $2 per order. Matinee tickets cost $10 each. The total cost in dollars of ordering in matinee tickets online can be found by using the function of n equals 10n plus 2. The table shows the cost of 1, 2, 3, and 4 tickets. Okay. So they have this table they want us to complete. So we're going to replace the value of n with the number in the position. So one ticket would be 10 times 1 is 10 plus 2 is 12. 2 times 10 is 20 plus 2 is 22. 3 times 10 is 30. 30 plus 2 is 32. And 4 times 10 is 40 plus 2 is 42. The domain of this sequence, remember that is my input, which was 1, 2, 3, and 4. The range of this sequence is my total cost, so it's going to be 12, 22, 32, and 42. What is the first term of the sequence? And remember, this is the term, or the position. So in the first position, the term is 12. We can find the difference between each two consecutive terms in the sequence. So if I take 22 minus 12, I get 10. If I take 32 minus 22, I get 10. And if I take 42 minus 32, I get 10. It says explain how the domain is limited in this situation. The domain is 1, 2, 3, and 4. What makes it limited is I can't say that the domain is 1 through 4, because then that would include partial tickets, and they're not selling partial tickets, they're selling whole tickets. The tickets are sold as whole units. Okay, so you don't want to do 1 through 4 because each ticket is one whole piece. Okay. All right, explain 2, constructing rules for arithmetic sequences. In an arithmetic sequence, the difference between consecutive terms is always equal. This difference, written as D, is called the common difference. And so this is from here henceforth referred to as D. An arithmetic sequence can be described in two ways, explicitly and recursively. As you saw earlier, an explicit rule for a sequence, the nth term of the arithmetic sequence is defined as a function of n. In a recursive rule for a sequence, the first term of the sequence is given, and the nth term is defined by relating it to the previous term. That's got that n minus 1 in it. An arithmetic sequence can be defined using either the recursive rule or the explicit rule. So we're going to write a recursive rule and explicit rule for the sequence described in each table. And it says that the table shows the monthly balance in a savings account with regular monthly deposits. Our saving account begins with $2,000 and $500 is deposited each month. So we're going to write the recursive rule. Remember, the recursive rule tells us what the first term is, and we know that our first term is 2,000. So our first term is 2,000. Then we take and subtract these two, and we know that the difference is 500. If I take 3,000 and subtract 2,500 from it, it goes down by 500. So there's our difference, is 500. So D is 500. our recursive rule is if the first term is 200, or 2000, then the function of n equals the previous term, so it's function of n minus 1, plus our difference, our common difference. And in this case, we know what that is. So we're going to replace that with our common difference, which we determined to be 500. Okay? So there's our recursive rule. If I were to write the explicit rule, we have a table here with three places. We have our first term, second term, third term. We can get that by taking our first term plus our common difference times our place. Okay, so if I take my first term plus my common difference times my previous, so x is going to be that n minus 1. So x is going to be this, okay? So 1 minus 1 is 0, and that's why this is 0. And so if I take 0 times 500 plus 2,000, my first term is 2,000. If I go to the previous one for the second one, 2 minus 1 is 1, so if I take 1 times 500 is 500. My first term is 2,000, so that's going to be 2,500. Then I have my third place, previous term, 3 minus 1 is 2, so 2 times 500 is 1,000. 1,000 plus my very first term, 2,000, gives me 3,000. Since d is always multiplied by a number equal to the previous term, you can generalize the result from the table. The explicit rule is 2,000 plus 500 times the previous term. And so this is our explicit rule. On B, the table shows the monthly balance in a savings account with regular monthly deposits. We have our months 1, 2, 3, 4, and 5. And then we have our account balance for each, which is our terms. And so we're going to write our recursive rule first. We know that our first term is 5,000. Oops, one more. And the common difference, if I take 6,000 minus 5,000, I get 1,000. If I take 7,000 minus 6,000, I get 1,000. So my common difference is 1,000. So the recursive rule is if the first term is 5,000, the function of n is the function of the previous term plus, 1,000. Now we can write the explicit rule. So for our explicit rule, we have our positions 1, 2, and 3. And then we have our first term, which is 5,000. So since we know our first term, we can replace it here. Times the distance times the previous term. Well, previous before 1 is 0. So 0 times 1,000 is 5,000. So 5,000. And then if I take my second, I'm going to have my first term plus 1,000 times my previous term to the second is the first term. That's 1,000 plus 5,000 is 6,000. If I have 5,000, that's my first term, plus my common difference times my previous term. 3 minus 1 is 2. 2 times 1,000 is 2,000. 2,000 plus 5,000 is 7,000. Since d is always multiply the number equal to the previous term, let's see, how did they write that? I want to make sure I get that the same. Yep, previous term. n minus 1. You can generalize the result from the table. The function of n is 5,000 times 100 n minus 1. The table shows the number of plates left at a buffet after n number of hours. Write a recursive rule and an explicit rule for the arithmetic sequence by representing the table. And what I do is I just start out identifying pieces. So I know that my first term is going to be this one right here, 155. My common difference, if I take and subtract these, 141 from 155, nope, that's a 1, is going to be negative 14 because I need to subtract this from this, so it makes it backwards. So this is negative 14. So there's our common difference. When we using our recursive rule, we have f. It could be either an a or an f of the function. So the function of n equals the function of n minus 1 plus, in this case, would be minus 14. Okay, and this is always possible because my recursive rule, or my first term, this only happens if the first term is 155. And you could put the if first term is 155 in front or behind. As long as you have it, it doesn't matter which one it is. When you take a look at the explicit rule, so this is the recursive rule. When you take a look at the explicit rule, we know what our first term is, we know what our common difference is, and we know that the function of n is going to be the first term plus your distance or difference times your previous term, right? Well, we know our first term is 155 plus our common difference is negative 14 times n minus 1, and there's our explicit rule. So here's our recursive rule, and here is our explicit rule. Okay, this is it for part 1. Please look for the video for part 2. If you have any questions, please make sure you talk to your teacher.